we'd like to take a look at what visually we're talking about when we have a plus b squared. Now we understand hopefully how to FOIL it, distribute it, and then how to pack it back up to make it look like this, to factor it. So it's as if we're talking about a is 3 and b is 5. We're talking about quantities. A could be any number, b can be any number. So if we have the numbers, this is easy. We just put in 3 plus 5 squared. Squared means times itself. So we add 3 plus 5 is 8 squared, which is 8 times itself, or 64 units of whatever, what we could talk about bricks. But sometimes we don't have both those numbers. So we've created a pattern to understand we can plug it in for any number. Or sometimes you'll have one number and one letter, like a plus 3. Okay, so what this means in algebra, we distribute it. A plus b squared means a plus b times a plus b times itself. So we begin to distribute 8 times a is a squared. We're talking about an actual square with the sides a and a. We have a squared. Okay, then we're going to have a times b, so a row of a times a column of b. That's kind of like this. It's like an a times b rows. Then we start to distribute the b term. B times a is ba, or ab. They're the same, right? 3 times 2 is the same as 2 times 3. So again, we have another one of b times b rows, a columns. And then b times b is b squared. So again, we're talking about an actual square whose sides are b, and b times b is b squared. So it's basically, we're going to have a square of a, we're going to have an a times b row and column, another one of the a times b, so there's 2, and then another square that's going to be b. Each side is b, and here each side would be a. So a quick way to show this or demonstrate it visually is to use what we call algebra tiles, but we just use some colors. So let's pretend a is 3. And so b could be like 8. Again, we can add 3 plus 8 and we know it's going to be 11. So to make a square out of it, we'd need another with the size 11. So I'd need 3 here, and then I'd need 8 here. I'm just estimating, right? And if we close this, we'd have a square. So what we're saying is, let me use green, a plus, we'll make the b green or brown, a plus b squared. Well, what we're saying is, take an amount, we use 3, but we'll take a, add it to another amount, call it b, and then make a square out of it. Well, then this means this would be also a, and this side would be whatever amount b is. Well, if we started to fill this in to make a square, what we'd see is a times a would be a square of a, right? Squares have the same side. Then b times this a would give you rows of b, columns of a. So it's a b by a row. B times a. Or a times b. Remember, those are the same. 2 times 3 is the same as 3 times 2. So up here as well, we have row of a times b. Well, it's a here times b here would be ab or ba. These are the same length or the same area. And then b times b would give you here a square. This side's b, this side's b. So b squared. So what we end up with are an a squared. If we really want to use the correct colors, we have a squared here plus an ab, I'll use 2 colors, plus another one, technically is BA, but they're the same as AB. And then, that's here. The final thing we have is a square here, a B squared. B there or B squared. So there's two of these. We have A squared, I'm not using colors now, 2AB, plus B squared. So hopefully you can see visually that A plus B, when we square it, becomes A squared plus 2ABs plus B squared, both visually and algebraically.